Alright, so let's talk about using your graphing calculator to graph a function. We're going to use the same example as in the prior video, which is this one. Alright, so we're going to use this example, this equation, and of course, just like before, you have to get it in y equals form. So if you want to solve that to y equals form, it should look like this. So you have y equals 2x minus 9 over negative 3. So going back to our graphing calculator, I have entered that. 2x minus 5, was it minus 9 or minus 5? 2x minus 9 divided by negative 3, not a minus 3. If we go to the graph, then simply it graphs it. And it defaults to the window of negative 10 to 10 on the x and negative 10 to 10 on the y. Let's try to graph a couple of maybe trickier ones. Or actually, no, let's change the window first, just like it had us do in this example here, to negative 520. Alright, what we're going to do is go to Window, and we're changing the what the x is changing from. So negative 5 to 20. Alright, and as you can see, that's going to change what our window looks like here. If it doesn't change automatically, we'll hit Graph. And now we can see more of the positive x-axis. A lot of times all we're going to care about is just the positive quadrant, quadrant 1, so we'll change our window accordingly. Alright, now let's look at graphing a few trickier ones. So if you notice where the highlighted cursor thing is, if I go to the side and hit enter, it now turns that function on. And I'm going to turn this bottom function off. Alright, so if we go to that function, you can see the slope is negative 0.001x plus 2.1. So what we're going to do is graph that, and you can see the graph looks like this. And it looks like it's got a slight downward slope. We can see that 1 pixel down, but that's not really very good, and it doesn't help us kind of navigate through that function very well. So if we want to see that long-term behavior, or better shape of the graph, what we're going to do is go to the window. Actually, what we're going to do is first go to the table and see if we can notice any trends. Now, this is a key thing to be able to play with your calculator and do this. You see, if we go to the table and go down, it changes very, very little. 2.0009, 2.089, 2.088, not changing by very much. So I would want to jump down numerous values to see when it actually hits the x-axis, gets down to y equals 0. So rather than hitting the down arrow a million times, what I'm going to do is go to Table Set. So that's second window. No, just second window. And I'm going to have it just start at 0, but I'm going to have it change by, let's say, hundreds. Now, you can see in the table over here, does it auto-compute? Nope, I have to actually hit it. Now I can see even quicker. And you know what? I actually want to jump even faster. So I'm going to go to Table Set, and I'm going to have it change by 500s. Now, if I go to the table, I can see that somewhere between 2000 and 2500 it crosses the x-axis. So if I want to be able to see both intercepts at the same time on this graph, what I would do is now go to my window, and I need my y value, or my x value rather, to be past 2 grand. I'm going to go to 2500. So what I do is I go to the window, and then I set my x max. I'm going to go to 2500 so it crosses. There we go. Now if I look at the graph, I can see where it crosses. And if I wanted to, if I still feel like it's kind of squashed, I can change my y value as well. Go to the window, and I only need to see from a y max of maybe, or a y minimum of maybe -1, and then a y maximum of like 3. Should give me a good picture of my graph. There we go. Now I've got both, and I can easily trace back and forth. If you hit the trace button, it'll lock onto your function and give you some approximate values. Okay, so now what if my values are wicked big? 550x plus 10,000. So what I'm going to do is turn this function off, or turn this function on, and I'm going to turn this function off. Alright, so now if I go to the graph, I'm going to certainly see nothing. Because my y-intercept is 10,000. There's no way to, I don't know why that didn't change. There we go. My y-intercept is 10,000. Of course, it's not going to be on that graph. So again, we look at these, and now my table is changing by way too much. Right? It's not even close. Like all of a sudden it goes from 10,000 and now we're up into the millions. So what I want to do is change by a bit less. And going to the table set and changing your table values and whatnot just lets you get a good feel for the function, so you can set your window to something appropriate. That's not what I wanted. Alright, so it starts at 10,000, goes up to 43,000. So what I'm going to do is, let's have my x go maybe between 0 and 100. And I'm going to have my y value start at 0. And we see from the table, if x is 60, y is 43,000. So I'm going to set my y values to be pretty big, and my x values to be much, much smaller. So let's set it to be maybe 10. So within 10, it goes from 0 to 10, goes from, the y is from 10,000 to 15,000. So let's go to a 20,000 max for my y. 20,000. Now if I graph it, that's a much easier graph to deal with if I'm trying to locate approximate values or study the behavior of some other kind of graph. Also, if you don't like this big thick line right here, what you can do is, in the window, your y scale tells you how far apart those tick marks are. So let's put those tick marks at 500. Something meaningful to our situation. Even still, that's way too big. So let's set those tick marks to 2,000. Now they're going to be a lot more appropriate to our function.